cost in energy, and the amounts are better measured in atoms than in ounces. Still, if we can make it in quantity, antimatter can achieve the 1g acceleration.
For the nearest stars, another way to deal with the fuel problem is simply not to take any fuel in the spacecraft. Pretty good idea, huh? You may be wondering how a spacecraft could get anywhere if it didn't carry any fuel. Well, what is needed is a way to burn fuel and have its energy applied to the spacecraft over distance. One kind of ship NASA has considered for traveling around to the various planets and to reach Halley's Comet is a sailing ship. But this sailing ship is powered by sunlight.
A spaceship with a light sail could accelerate continuously on a journey to the outer planets. Light particles rushing out from the sun propel the sail and the craft to its destination. Also, like a sailing ship on the sea, the sail can use the power of light to sail back towards the sun. But ordinary sunlight has its limits. There's not enough sunlight to push it into interstellar space, so if we want to use solar power to get us to the stars, we'll need to amplify the sunlight considerably, perhaps with a huge sun-powered laser.
When you look at interstellar distances and you think about having to accelerate all the fuel that it takes to travel at the speed you want to get to the star, the idea comes up of what if we left the power plant at home and projected the energy, transmitted the energy to the spacecraft by a beam, a microwave beam or a laser, a photon beam. And so the laser cell or the solar cell uses the sun's solar system. The laser cell uses a high-powered laser left in the solar system, probably near the sun and an orbit around Mercury, and it projects a beam out that pushes on the cell that accelerates it to very high velocities to let you would need for stellar travel or travel to Alpha Centauri anyway.
The craft's sail would be enormous, over 650 miles across. Huge size would be necessary not only to send the ship on its way at half the speed of light, but also to slow it down when it reached the target star. A trip of this kind would take great faith on the part of the crew. They would have to trust people back in our solar system to start and stop the laser at the appropriate times. The round-trip time using the propulsion system would roughly be 50 years for nearer stars. We'll return to the Practical Guide to the Universe on the Learning Channel.
The blackened coil unwinds. A big difference.
We now return to the Practical Guide to the Universe on the Learning Channel. Light sails and lasers take us well into the next century, but the visionaries have propulsion systems in mind for the centuries beyond. One such futuristic mode of transport is the hydrogen ramjet. For fuel, this craft would collect the sparse hydrogen atoms in deep space with the help of an enormous funnel. The ramjet technology is still far in our future, but it would tap into an unlimited supply of free fuel, and therefore unlimited periods of acceleration. This hydrogen ramjet could reach velocities close to light speed. Craft could experience the strange effects predicted in Einstein's theory of relativity. The theory of relativity states, in simplified terms, that time slows down as you approach the speed of light. Not just clocks, but all life functions slow down as well. Therefore, an astronaut moving very quickly through space ages more slowly than we do on Earth. Were we able to look inside a spaceship traveling at near the speed of light, it would look to us as though the people were frozen and their onboard clocks were stopped.
Now this is a strange concept and difficult to fully understand, to say the least, but it is a fundamental truth. It's already been tested with matching atomic clocks placed aboard spacecraft in orbit and mounted in laboratories on Earth. And in every case, the clocks brought back from space showed less time had passed than the clocks in the laboratory. So what this means in a practical sense is that the closer you're moving to the speed of light, the slower time will pass for you relative to those on Earth. So in essence, you're going to live a lot longer than your pals if you're traveling in space.
For example, if you traveled to another star and back at nearly the speed of light, you might feel as only, say, 12 years or so had passed. Physically and mentally, you would be only about 12 years older. But your friends on Earth would have grown old and died before you returned. This could pose some psychological problems for the crew.
The bottom line is, how do you understand the psychology of doing something and having the environment you're used to change at a rate different than that which you're changing? I mean, if I aged 1 year traveling around the solar system at 0.9 c, 0.9 the speed of light, even around near galaxy, and came back in a year, and everyone else had aged 4 years, or 40, I mean, how would I accommodate that?
On this spaceship, the crew would be almost immortal to our eyes on Earth. You see, once the ship has accelerated close to the speed of light within our galaxy, it could coast to a neighbor galaxy. The people on board wouldn't age much in relationship to us back on Earth, as long as the ship kept moving at that speed.
For all practical purposes, the trip would be one way, in the sense that it would not have any direct benefit for the generation of people who remained on the Earth. If the ship visited the closest spiral galaxy to ours, Andromeda, and then returned, the crew might be only 10 years older, but on Earth, over 4.5 million years would have passed. Pretty scary, huh? For the crew, it would be as if they had traveled millions of years forward in time. This is time travel in the truest sense, but at what cost?
One wonders what they would find upon return. Would the human race still exist? It's possible. Our solar system might be thriving with lush green worlds created from the sterile planetary bodies we found in our first explorations. Perhaps we would have huge colonies free-floating in space. There might be some sort of commerce with nearby stellar systems, and possibly contact with intelligent aliens. On the other hand, the returning travelers might find the planets unharvested, the Earth itself devoid of any but the most primitive life forms, struggling back from a colossal extinction. It has happened before, and we could bring it on ourselves. A good reason to become established on other planetary bodies is to assure the preservation of human life and Earth's supporting ecology should disaster strike our planet. In the same vein, travel to other stars would assure continued life if a disaster was to strike the entire solar system.
But it's a small investment for a payoff that could actually provide some kind of lifeboat for the Earth in the event of catastrophes beyond our imagination, and being able to consider living off this world. And I don't think that's unrealistic. It's just hard to imagine because perhaps, like me, a lot of people have read science fiction, and you read about this and think, yeah, right, great, science fiction. But it shouldn't be. I mean, NASA has talked about missions, that you could start now to the nearest star using controlled nuclear propulsion systems. And basically, you launch it now, and you let 2 generations from now analyze the data. And, are those missions really as crazy as they sound? They're investments in a future that a lot of people nowadays aren't willing to make. I mean, think of the construction of the great cathedrals of Europe. Very often, they took 150 years.
But why worry about space travel now with the multitude of problems here on Earth? Sound familiar? Well, 30 years ago, President John Kennedy answered that question with words that are still true today.
So it is not surprising that some would have us stay where we are a little longer, to rest, to wait. But this city of Houston, this state of Texas, this country of the United States was not built by those who waited and rested and wished to look behind them. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills, because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
We have begun to develop the ideas that will give birth to the reality of journeys to the stars. From our small beginnings of ships and airplanes and rockets, we are now on the road to greater adventures than have ever been dreamed possible. For we are most certainly destined to become space and time travelers.
Next on the Learning Channel.